Problem 4 is really a combination of problem 3 and 4 together. In order to solve this quadratic by factoring, we need to first factor this left-hand side. So I'm going to break it up into its two binomials. To factor x squared, well, that's going to be x times x. Then we have to think about this 2. And what are the factors of 2? Well, 2 is prime, so it's only going to be 1 and 2. So those are my two options right there. We need to check it, and how we do that is by checking the outside and the inside. And on the outside here, we'll have 2x, and on the inside, we'll have 1x. And we ask ourselves, can I take this 2x and 1x in order to make a 3x? And yes, of course we can, if it's plus 2x and plus 1x to make plus 3x. All right. Now that it's factored, we're multiplying two factors together to equal 0. So that means that either the first factor, x plus 1, is equal to 0, or the second factor, x plus 2, is equal to 0. If x plus 1 is equal to 0, x equals -1. We get that by just subtracting 1 from both sides. Or we subtract 2 from both sides in the second equation to see that our other option is that x is equal to -2. And those are our two solutions. In the next one, x squared plus 12x plus 36, we have to factor the left-hand side into x and x. And the factors of 36 are either 1 and 36, 2 and 18, 3 and 12, 4 and 9, or 6 and 6. And so we want to think of one of these pairs that can make 12. Because when we do the outsides and insides, it should come up with 12. Well, 1 and 36 make 37 or 35. This makes 16 or 20. 3 and 12 will be 15 or 9. 4 and 9 will be 5 or 13, but 6 and 6, that's how we can make it 12. We'll get 12 if we had plus 6 and plus 6. Now that it's factored, take each factor and set it equal to 0. So either x plus 6 equals 0 or x plus 6 equals 0. Well, since these two are the same, I don't really need the second one. I could just solve this first one. And I'll do that by subtracting 6 from both sides. And x equals -6. When you have a polynomial of x squared minus 25 is equal to 0, don't be tempted to add the 25 to the other side and take the square root, because the directions clearly say solve by factoring, so we have to factor this first. Luckily, it's one of the easier ones to factor because it's the difference of two squares. When I have a perfect square minus a perfect square, it's going to factor into x and x, and the square root of 25 is 5, so 5 and 5. One of them is going to have to be plus, and the other one will have to be minus, so that those two middle terms will cancel each other. Then we go ahead and set each factor equal to 0. And solve. So here I'll subtract 5 from both sides to get x is equal to -5. Or I will add 5 to both sides. Those two cancel. And we get x is equal to +5. And those are the two solutions. One last problem that's a little bit more difficult is 2x squared minus 8x minus 90. And you might be nervous about that 2 that's in front. One thing that we can do when we're factoring is to first, I notice that every single term is even. So how about I factor out a 2 before I even get to breaking up into other factors. So when I factor out a 2 out of the 2x squared, I'm just left with x squared. And I take a 2 out of 8x, I'm left with 4x. And -90 divided by 2 is -45. That leaves me with something that's a little bit easier to factor. X squared will factor into x and x, and 45 will factor into 9 and 5, because -9 plus 5 makes the -4 that I need. Now we set each factor equal to 0, so technically either 2 equals 0, or x minus 9 equals 0, or x plus 5 equals 0. Well, 2 is never ever going to equal 0, so I don't have to worry about that one. If x minus 9 equals 0, then x is equal to positive 9. Or if x plus 5 is equal to 0, x is equal to negative 5. And there's our two solutions.